truth. It keeps cropping up, and as it should, it's an indispensable feature of the reality we occupy. Physical and abstract. We come to know the truth, but never the final truth. We can, with some effort, through our good explanations, manage to find some truth some of the time, but we never find the whole truth. And so our explanations are always a mixture of misconception and some account of reality that's accurate or true. But the conjunction, in other words, the logical and operator of some amount of misconception or falsehood and some amount of truth is a falsehood. That's how logic works. And so everything we claim about physical reality is a mixture of misconception and truth. And we can't articulate truth. David Deutsch has a wonderful way of articulating what the properties of truth happen to be. Namely, they apply to propositions, to these perfect abstract idealizations in formal logic or mathematics, that kind of thing. Those have truth values. Propositions have truth values. And so if you do formal logic or mathematics, the variables, which you call propositions, or rather symbols that stand in for propositions, are kind of like the relationship that numerals have to numbers. Numbers exist abstractly. They are perfect in a sense, occupying the abstract realm. But the way we represent them is always an imperfect numeral of some kind. And there are lots of equivalent ways of representing the same number using different numerals. But truth is, as I say, indispensable. We don't want to give up on the concept of truth, or pursuing truth, or seeking truth, which is something I've spoken about before and written at length about before as well. The thing is, though, it can be misleading because some people think that the search for truth can lead you to a final truth in some way. And it leads people to make egregious errors. So, for example, the legal system has within it this critical error at its heart. I think in America, in court, when you're asked to testify, you're asked to say something like, the truth, the whole truth, and nothing but the truth, so help you God. But you can't speak the truth. You certainly can't speak the whole truth. The best you can do is, and really what the judge and the court and the legal system should be requiring of you is not to lie, not to deliberately deceive, not to say the thing you know is not true in order to, as I say, deceive people, pull the wool over someone's eyes, be corrupt or lie, steal, cheat, that kind of thing, all the bad stuff. The greatest entrepreneur of our day, Elon Musk, is apt to talk about truth quite often. As is Donald Trump. He has his version of Twitter called Truth Social, and I think he calls his posts there truths. But Elon Musk said back on December 12th of 2024, the exact thing that I quoted before, the truth, the whole truth, and nothing but the truth, is critical to the evaluation of any AI model. But is it? After all, we don't know what the truth is. All we have are better and worse explanations. As I've said before, following Popper, you can replace the search for truth with our attempts to identify and correct errors. Fundamentally, when you break down what people really mean by seeking truth, it may well collapse into nothing but that. In other words, people who say they're searching for the truth are kind of searching for something that works, and they do this by a process of error correction. It's all they can do. So Elon Musk, when he says he's searching for truth and he places a primacy on truth in social media or elsewhere, as David Deutsch has pointed out, when people excel in something, they excel there because they're being Popperian in that particular domain. So he has the best rockets on Earth, or among the best rockets on Earth, because of this process of conjecture and refutation, trial and error, finding errors, things that don't work, and correcting them, solutions to his problems. It's all very Popperian. Now, he might very well say he's seeking the truth. And okay, very well. But he's never going to get to some sort of final truth. What would it mean to have a final truth about a rocket anyway? The perfect rocket, the ideal rocket, the rocket which could not possibly be improved? No. So what does it mean to find the truth? Well, in that sense, It's just a pragmatic consideration about what works and what works better. But that is also true, you see, I can't avoid the word, of theories that we have in science and ideas that people have. This fact that we cannot get to the final perfect ideal, the capital T truth, but all we can do is improve. If we did have truth in hand, then it wouldn't be improvable. After all, it's the truth. There's no error in it. And so there's no point debating it any further because you have the final word on the topic. You've got the truth. Now, hopefully, no one rational, reasonable, actually ever thinks this. Instead, what they think is they have a very good idea. The best idea they know, the best idea anyone knows. But they could discover a misconception they have about it at any point in the future. They could find an error and then they'd want to improve it, move to somewhere better. And having that expectation operating in your mind all the time is the way in which to think rationally. To think, this is the best idea I know. You might even think, this is the best idea that anyone knows. But it's not perfect. I hope that with some effort, I can make progress by perhaps finding an error in it, correcting it, moving forward, improving. This is what the search for truth, or error correction and progress, or seeking good explanations is really all about. Moving in the direction of correcting errors that you've identified out there in the world. That's an objective process. And that's something that actually you can physically figure out whether or not you've done, you've accomplished. You can never figure out whether or not you've found the truth. After all, how do you justify having found the truth? How can you prove you've found the truth? You'd have to prove, for example, that the process you've used in order to get to the truth was itself inerrant, perfect. And that leads to an infinite regress. How do you know the argument that the process that you've used, which you say is inerrant, that's led to the final truth, is itself a valid argument that has no error? And so it goes. So instead of worrying about all of that, that chimera, that red herring of a way of going about discussing philosophy, mathematics, science, and so on, why not just appeal to ever better explanations? Why shouldn't that be your motivation? That be your criteria for making progress? And it is. And it also means that progress won't ever end. These are the things that I've talked about very, very often. So I say truth is an indispensable feature in our discussions of rationality and reason, civilization. We don't want to do away with it. We're not relativists. There's something to be wrong about. That's reality. And we can say falsehoods about it. We can make a claim that doesn't work, that's ugly, that's a lie, and so on. So we can be wrong, which means there is a truth to be wrong about. And truth, again, is a property of propositions. And what are propositions? Well, propositions might be idealizations about the nature of reality, let's say. But reality is also a thing we cannot get to in any final sense. What are we trying to get to that reality? We're part of reality. We're continuous with reality, if you like. However, the rest of reality beyond our minds is separated from us by channels of information. We are minds, after all. And people might very well say, well, you can have a sensation while meditating or in some other state of being selfless, of not having a self, not being separate to the rest of physical reality. And okay. However, there is a real mind and you are a real individual coming up with explanations, having sensations, experiencing the world, conscious of what's going on, creative. You exist. However, how you exist is in your brain in some way. You're a mind, and you are connected to the rest of physical reality via, well, when you're looking at things, the optic nerve, when you're listening to things, the auditory nerve, when you're feeling things via all the tactile sensations that are connected to the cells that make up your skin and so on. A nervous system is what is connecting you to your creative mind, allowing you to be consciously aware and make decisions about what to do next. And in particular, to create new options in the world, which is the existence of free will. A lot of people complain about my position here on free will, but what I say free will is something deeply connected to our capacity for creating explanatory knowledge. And in particular, creating options that weren't there before. They weren't there in some sort of unorganized way and we just repackaged them. Although if they were that would also be a creative act. No, rather, they weren't there in any form. We create something entirely new. The first person to ever bake a Christmas cake came up with something genuinely new, even though it's made of flour and water and fruits that have been soaked in alcohol for some time. That was something that was done for the first time, and it's not like any amount of looking at dried fruits and flour and water and sugar and all the other ingredients would allow the typical person to just go, there is the Christmas cake. No, it's not, doesn't work like that. That recombination in specific ratios with a specific shape and all of the other constraints that apply to making a good Christmas cake had to be created, invented by someone. That's what a person does. And the recipe for that, not in the genes, and certainly not in the laws of physics either. Now, truth is often tied quite closely to the concept of belief as well. Belief is a psychological state. A person has beliefs, apparently, but books don't have beliefs, walls don't have beliefs, telescopes don't have beliefs. What is belief really? Well, when someone claims to believe something, but in fact tells you almost nothing about their psychological state, except that they are having this experience, so they claim, of believing something. But believe has two almost completely opposite meanings, and I've made this point before, and I'll make it again now. On the one hand, when certain religious people say they believe in God, they mean they have a feeling that is stronger than almost any other. They have a certainty, a confidence that is at its absolute maximum. I believe in God. When I was a child, going to a Catholic school, we were required to recite the Nicene Creed. And it went something like, I believe in one God, the Father Almighty, the maker of heaven and earth, of all that is seen and unseen. And so it went. I'm not sure if you can hear the thunder that just went off outside now. I don't know if that was a message from heaven or not. Anyways, I will persevere at possible risk to myself from the heavens above. Anyway, believe can mean the thing that you're the most certain about, the thing you have your highest confidence in. But on the other hand, it can also mean the thing you have the lowest confidence in. Do you know what John's doing for his birthday? Oh, I believe he might be having a party, but it's not on the actual day. It might be on the weekend following. In that case, the person is not claiming to be absolutely certain, highly confident. In fact, using the word believe in that way is indicating the opposite to certainty. I'm completely uncertain. So on the one hand, believe can mean certain, and on the other, it can mean completely uncertain. So if you say you believe something, or if you hear someone else say they believe something, you don't know. Some think belief can exist on a continuum, that you can be highly confident and grant a lot of credence to certain claims, things that you strongly believe, or things that you have no opinion on, through to things you disbelieve, which is just the mirror image of believe, and so you're just believing the opposite thing, or at least rejecting the thing that you otherwise would strongly believe. So to disbelieve something would mean you believe that it's not true. On the other hand, believe means you think it is true, which is how this concept of belief is connected to truth. If you strongly believe something, you think it's true. And if you don't, you think it's not, or it could be. These concerns about truth and belief, I argue, are not a part of epistemology. No, I'm not the first one. Karl Popper said he's not a philosopher of belief, nor am I. I'm not even a philosopher. But what I do say is, belief is a red herring. It just gets people tied up in arguments about whether or not they can justify their beliefs and to what extent they think something is true. Rightly considered, this whole discussion about belief, if indeed it's useful at all, is a part of psychology. What's going on in people's minds? And that's not really ever been much of my interest. And insofar as psychology is a domain of study that's worth pursuing, and I think it is. I think there are two arms to psychology. On the one hand, the theoretical academic side of things, which really should focus on memes, because memes are in part ideas that control behaviour or cause behaviour in people, and indeed entire societies, which leads to a mimetic understanding of sociology. And the other arm of psychology is really about something approaching cognitive behavioural therapy. It's about therapy, trying to help people work through their problems. Problems always begin in the mind, of course, with ideas, and so however one feels is often dictated by the ideas that are ruminating around their head when it becomes a negative form of psychology. I find epistemology more fun because we can talk about knowledge rather than belief, and knowledge becomes a binary thing. Either you know something or you don't know it, which means you have a good explanation or you don't have a good explanation. In between these two extremes, you're just wildly guessing. If we consider epistemology, the subject, as being about knowledge, then it becomes far more neat a domain of inquiry when we consider that it's a binary, whether or not you know something. Either you know something, which is to say you've got a good explanation, or you don't know something. And sometimes when you don't know something, you might have a bit of a guess about it. It could be a random guess or an educated guess, let's say. But either you know it or you don't know it. And by know, what we do not mean is are absolutely certain of, or indeed feel confident in any way. All it means is you have an explanation and you understand it, that accounts for the thing that you want to explain. And so knowledge in the Popperian sense, and the way that David Deutsch explains it, and the way that I explain it, is far closer to the common sense understanding that people have about this word to know. Because when you get to K-N-O-W, know, in academic and intellectual circles, it becomes divorced from the common sense meaning. And instead what you end up with is gradations of justification. And something more like the stance that you have the truth in hand, or most of the truth in hand, let's say, and that there is perhaps even a number that you can assign as to how probable this thing that you know happens to be. And so intellectuals might try and trap people, the average person on the street, in arguments about how much evidence they have and how confident they are that some particular thing is true, and therefore whether they should believe it, and therefore whether they're justified in claiming to know it or not. But if you're a Popperian, you can say that you know something and simultaneously admit that you don't believe it. Or indeed, you know something and simultaneously know that it's false. Or know something and say, it's impossible for me to justify this thing. What you can say to someone who challenges whether or not you really know something is to say, yes, I really know it because I can give you an explanation of that thing. But are you sure the explanation is correct? No, I never am. I'm not sure about anything. But I do have a good explanation, and it does account for the thing that you're challenging me on. On the other hand, if someone traps you in a discussion about to what extent you're justified, and you provide this justification, they can always turn around and say, well, how are you justified that that justification is in fact true? Now, the example I always deploy at this point is Newtonian gravity. So let me go through it again. Newtonian gravity is almost a Platonic ideal as far as instances where this is illustrated. I'm joking there, of course. But it is a great example of what's going on when people try and talk about knowledge as being justified, true belief. That knowledge can only be a thing if you are justified in believing it, and you would only believe it if you know that it's true. Every physics student learns at some point Newton's law of gravitation, the inverse square force law for gravitation. What it is a formula for predicting the strength of the so-called force of gravity between two objects, often the Earth and something else. And the formula goes F equals G m1 m2 over r squared. Or sometimes big M little m over r squared, where the big M is the big thing and the little m is the little thing. You multiply those two things together, you get a product, you divide by the square of the distance between their centers, and you multiply by this thing called G, which is the universal gravitational constant, the number that fixes the strength of gravity throughout the universe. And F is, of course, the force in newtons. Now that, Newton's universal law of gravitation, was a magnificent advance on what had gone before, namely Copernicus, then Galileo and Kepler, who all had cosmologies, ideas about how the universe worked and what it consists of, and to try and predict things like orbits. We had to wait until Newton till we got a universal law that applied not just to the solar system, but to all objects anywhere that were attracted to each other. And the thing is, and as I've been at pains to explain on Topcast before, this formula is extremely useful. It can be used by geophysicists, for example, and indeed is to this day. I've talked before about my own experiences carrying these things called gravimeters, gravity meters, around campus and various other places in order to measure the gravity down to like the 7th or 8th decimal place, 9.812645, and so it goes. And you would plonk it down, it would give you the reading, then you'd pick it up and you'd carry it 10 meters and you'd plonk it down, and you'd take a different reading. The gravity would subtly change throughout all of planet Earth, or over the 100 square meter grid over which you were taking measurements. And why would you do that? Because the strength of the gravity would tell you what's beneath the subsurface, to some approximation. You'd have to have other theories as well. For example, are you looking for a cave, in which case the gravity is going to be slightly less? Are you looking for iron ore? The gravity might be a little bit more. You'd have to do all these corrections for things that might be around you. There might be mountains nearby, you have a certain latitude, which is going to affect things, and anyway, so it goes. In order to use that gravity meter and to do the calculations and the corrections that you needed to, you were relying on Newton's law of gravitation. You didn't have to worry about general relativity, which is our best theory of gravitation. In fact, when NASA sent astronauts to the moon, in order to plot the trajectories, they weren't using general relativity, but Newtonian gravity, because it works so well. It works for engineers, it works for rocket science. Newtonian gravity is extremely rich. Classical mechanics using Newtonian gravity can get marvelously sophisticated when it comes to trying to predict what happens with numerous bodies orbiting each other. Just because that formula is relatively simple doesn't mean that, for example, the three-body problem that is governed by it to some approximation is made any more simple. No, it's just as complicated. Add 4, add 5, it gets extremely complicated. So here's the thing about Newtonian gravity. I know it. I've just put it up on the screen and explained it to you, so you know it too. Every physics student knows it. Engineers know it. Geophysicists know it. People know Newtonian gravity. It constitutes knowledge. But as we've also mentioned before here, we know it's false because it gets certain things wrong. For example, trying to predict precisely where Mercury is going to be, it gets that wrong over time. Perhaps more importantly, the crucial test that was performed, I think in 1919, designed by Arthur Eddington, where he compared the predictions of Einstein's theory of general relativity and how much light from stars was going to be bent by the sun as that light passed by the sun during a solar eclipse. So the moon got in the way, the sky went dark, you could see the stars, and therefore calculate, using special instrumentation and the knowledge of an astronomer, how much the light was bent during that eclipse. According to Newton's, it was by some amount, and according to Einstein's theory of general relativity, a different amount. And as it turned out, it was correctly predicted by Einstein's theory of general relativity, ruling out Newton's theory of gravity as being the correct one. Newton's theory of gravity was not the correct theory. In other words, it's strictly speaking false. Not utterly false, it's better than some random guess. It's better than an inverse cube law, which would get things completely wrong. But for a bunch of technical reasons, it's just a low mass, I'm talking about Newton's gravity now, it's just a low mass approximation to what is going on in reality. We should expect the same, by the way, for general relativity. General relativity, in the final analysis, is going to turn out to be false. Among other things, it doesn't work well with quantum theory. And one reason why is something that I've alluded to already, orbits, predicting orbits. In order to predict an orbit, what you want to do is to know where a particular object is at this particular moment so that you can predict where it will be at some point in the future. Now, in a single universe theory of reality, that's unproblematic. You could have a particular point in space to arbitrary precision about what the location of that object happens to be. For example, the Earth, when we say where is the Earth, we want to know where precisely is the exact center of the Earth right now. And then, using something like Newton's theory of gravity, or indeed general relativity, we can use the equations of motion to predict where it's going to be in the future. If we're talking about general relativity, we can be arbitrarily precise with exactly where, what the position of the centre of the Earth happens to be if we had really fancy instruments. And imagine we are in the distant future where we could measure to exceedingly high accuracy where the position of the Earth's centre was with respect to the Sun, and how fast it was going as well, by the way. Then we could predict, using the laws of motion, general relativity, where it's going to be in the future. But here's the kicker. In reality, in order to know the position of an object to arbitrary accuracy, something like the centre of the Earth, which is going to be an infinitesimally small point, it is governed by quantum mechanics. In fact, everything is governed by quantum mechanics. And quantum mechanics says there can be no super, infinitely, arbitrarily precise position for the Earth. It's spread out like an ink blot. It occupies not one position, but many. This is where general relativity and quantum theory don't quite agree with one another. General relativity requires, in order for predictions to be made, an arbitrarily precise, a single point in space in order to make a prediction about what the orbit's going to be like. But quantum theory says you cannot have that perfectly precise single point in space. There's a range, and so therefore there's going to be a range of orbits. But we don't see a range of orbits. We see one. And yet our universe is governed by both general relativity and quantum theory to some approximation. In reality, there has to be a single theory. There has to be one set of laws of physics. So how do we reconcile this? We don't know yet. No one knows. That's why they're working on the unification of quantum theory and general relativity. But the multiverse says that as the Earth goes around the Sun, it is following subtly different trajectories, precisely because of this issue that the Earth does not have a single position in space, but many. When Eddington's experiment was performed, and ever since experiments have been performed, whose outcomes can only be explained by recourse to general relativity and not Newtonian mechanics, or Newtonian gravity rather, because we know Newtonian gravity fails, it doesn't work, it's false. That means you shouldn't believe Newtonian gravity. You're not justified in believing Newtonian gravity. It is not a justified true belief. No one should believe it. You can't justify it as true. Indeed, you can show that it's false. Everything about this conception of knowledge as being justified true belief, or justified to some extent, or probably true to some degree, is wrong and wrong-headed. Knowledge can be false. Knowledge is useful information, as we like to say over and again here. That is why Newton's law of gravity counts as knowledge. It doesn't count as a good explanation anymore in light of the existence of general relativity, but it counts as knowledge. It's a particular piece of information that has causal power in the world. Namely, people use it in order to construct stuff, build rockets and get them to the moon, and gravity meters and figure out what's in the ground so they can dig it up, and lots of other things besides. Newtonian gravity can be used to solve problems. And because it's information that solves a problem, it tends to get itself copied. Or information that instantiated in a physical substrate tends to cause itself to remain so. In other words, because it's been so useful in the past at solving problems, it's passed down from generation to generation, from physicist to physicist, engineer to engineer, rocket scientist to rocket scientist, because it's so useful. It is information that is getting itself copied, perpetuated throughout generation after generation. Maybe one day it won't be anymore. Maybe one day we'll have devices for people to perform calculations using general relativity that are arbitrarily small and easy to use, and no one will bother with Newton's theory of gravity, and it may well get forgotten except as a part of the history of physics. But we're not there yet. How is knowledge like that created? How are good explanations created? How did Newton create his theory of gravity? How did Einstein create his theory of gravity? How did Darwin come up with the theory of evolution by natural selection? How did Turing come up with the theory of computation? How did David Deutsch come up with the theory of quantum computation? How did Karl Popper come up with critical rationalism, or epistemology as we best understand it? These are creative acts. You hear some people downplay creativity and talk up reason. I don't mind that. We can use whatever words we like. Generally, when I use the word reason, I'm referring to all the ways that we try to come to an understanding of objective reality, of which science is a part, history is another part, mathematics is another part, and so on for subjects we yet to even have names for. But all of that is a deployment of reason. How do we improve our capacity to reason or to use reason or to continue the age of reason? Well, it's by a rational means. What do I mean by rational? What do many people mean by rational? I mean a focus on finding errors and correcting them. That's how we make progress. So rationality, the process of finding errors and correcting them, is used in our reason in order to come to understand reality, which is why I've got that other podcast, by the way, Rationality, Reason and Reality, or something like that. Anyway, it's called the 3 R's. Go and look for that. I might upload this episode there as well. But whether or not you like to say that people are a unique species because they reason, correct, or because they have the capacity to generate explanatory knowledge, correct, they are special. People are special, despite the fact that others like to downplay their significance in the cosmos. Whether it's reason or creativity, this unique feature that people have, when we are actually engaged in creative pursuits or using our reason, we find it enjoyable. It's objectively enjoyable. Unless we're being coerced in some way. In other words, you've been imprisoned against your will and now you've got to use your reason to try and escape. That might not be so much fun if you're under fire at risk of being put to death if you don't escape in time. Okay, I get that. There are edge cases involved. But in a free society, the free use of our reason in order to be creative and generate knowledge is fun. And it enables you to be in a kind of a flow state. Have you ever been for a run at a beach that has lots of rocks around? Here in Australia, we have wonderful beaches, as many people know. And we also have, at many of those beaches, large rock platforms, usually igneous rock flows that were formed many millions of years ago, and they're often potted in places because of rain or perhaps volcanic eruptions have caused these big holes to appear on the ground. And I haven't done it for a while, but I certainly remember as a child and a teenager and as a person in my 20s, I'd go running along a beach and then I would find the rocky platform and go running across it. Now, the relevant thing here is that I didn't know how I would get from A to B, from where the rocks began on the sandy side of the beach to the other side of the beach where the sand was there once more. In between, lots and lots of rocks that you had to scramble over. Now, if you're in a flow state, you're not really thinking about where to put your feet exactly. It's all happening unconsciously. It's like your eyes are connected directly to your legs and your feet. You're not thinking, okay, I better avoid that. You know, there's no explicit explanations going on inside of your head. You're simply avoiding the obstacles and putting your feet precisely where you want to go. Now and again, you might slow down or even have to stop and backtrack. But in general, you make rapid progress if you're well practiced at this. This is being in a flow state. That's a physical manifestation of it. Anyone who's a good tennis player knows what it's like to just know where you should try and hit the ball. Anyone who goes surfing understands what the flow state is, where your mind isn't really there consciously. Your body is just moving in a way that later on, retrospectively, you can try and account for with words, but you'll never quite be able to capture. The same kind of flow state, which is creating the knowledge on the run, because literally when I was running across the rocky part of the beach, I was creating knowledge, okay? The knowledge of how to get from A to B without tripping over and hurting myself. The same kind of sensation, not exactly, but similar, when one does mathematics relatively proficiently. You can be given a problem, you can start somewhere and not know exactly how you're going to get to the end. You kind of have an idea about what the end point should be. Simple problems often were given in high school or at university, like, you have an arbitrary sized container of certain dimensions that happens to be a cylinder of radius r of height h, and a tap is filling it up at x milliliters per minute or something, and then you have to figure out a generalized equation for how long the thing will take to fill up, and so it goes. It could be fun sometimes to work through a puzzle like that. Or the logistic equation was one of my more fun ones. This was an attempt to model things like population growth. So rabbits bred at a certain rate, and assuming no constraints, the rabbits would breed exponentially. But as soon as you added some constraints like there are foxes in the area eating the rabbits, or there is a restricted amount of food, or the rabbits were camouflaged against the grass or not, you would have this logistic equation which could gain increasing complexity to enable you to figure out whether or not the population of rabbits would go extinct, or whether they would continue to increase and at what rate they would increase, and that kind of thing. That could be fun, and you could find yourself in a flow state. Or chemistry was another one. Esterification was an enjoyable one for me, where you can add an acid, usually it was an organic acid of some kind, and you add it to an alcohol, or an alkanol as the technical term goes. You put these two things together under reflux and you can produce this thing called an ester, which is a smelly thing. Sometimes they smell very nice. The characteristic smell of a banana or the characteristic smell of an apple is due to this chemical called an ester. And before you do the experiment, or I should say demonstration of how the manufacturing process works, people learning this stuff can learn not only the reaction, but the precise quantities, the concentration of the acid, the amount of the alcohol, the temperature at which you want to do this reflux reaction under condensation happens to operate at most efficiently, and you can predict what quantity of ester you'll get out at the end. So all of this can become really fun because you're doing science. You've got a theory, you're predicting the outcome of the theory, and then you're demonstrating that it works. And if it doesn't work, you've likely made a mistake unless you've discovered some entirely new chemical process. Those examples are examples of situations where you're creating the knowledge. You're doing the mathematics, or you're doing the exterification reaction, or you're running across the rock platform at the beach. Other people might have done this before, but for you, it's the first time you've ever done it. So you're creating the knowledge in your mind the first time ever. Now, the lucky thing for you is, perhaps in some of those situations, because someone else already got there first, you've got a few hints and tips, you've got some clues perhaps, and that can give you an advantage. But nevertheless, you still have to go through the trial and error process of guessing what the instructions on the page happen to mean, and checking to see whether or not the conclusions do indeed follow, whether you understand everything, whether you can recreate the explanation in your mind. And if you're interested in all of that, if you're curious about that, and no doubt you have a particular thing that you are interested in, that you're curious about, it's fun. It's fun to learn that thing. And it's a whole other level of fun, it can be, once you get to the end of knowledge, so to speak, by which I mean the end of what people presently understand, and realize there's a place upon which you can build or contribute to the knowledge. That can be even more fun because no one's ever been here before. No one's tried to solve this particular problem. And sometimes you can be wrong about that too. You think that you're going to be the first to discover this particular thing, but in fact, you're rediscovering something that someone else discovered and perhaps put a lot more effort into. I remember all the way back in year 7, so I think I was about 12 years old, I figured out that school was a prison, and I used to go around saying this to people, that school is a jail. Now, I quite enjoyed school, but I remember telling my teachers, this is like a prison. The only difference is that the inmates haven't done anything wrong. They don't deserve to have been in prison. Because although I was rather enjoying my experience at school, I did like science and mathematics and that kind of thing. I treated it as a bit of a competition, and hey, who doesn't like to win? I could see that other people didn't. And because other people didn't, I felt for them. And I thought it's unfair that they have to be forced to be here, learning things that they weren't interested in. And I got that. I didn't see why other people had to learn science when it was something I was really into. But meanwhile, the kids who were interested in football weren't allowed to play football whenever they wanted, and yet I could read as much science as I liked until I went off to the art class, and then I had to do art. But even then, I didn't mind so much. My point here is, I thought I was the first to think of school as being a prison. And not until well after I left school did I realize lots of people had that idea already, and lots of people had indeed entire philosophies about not merely school being a prison, but lots of structures about the way in which children were raised were like prisons. I remember also, and this goes to my being raised in a Catholic school, that selfishness was bad, I was told, and being altruistic was good, and that if you gave charity, that this was a good thing. And I remember, even as a youngster, even as a child at school, thinking to myself, but hold on, those people who give charity, they do it because it feels good on the one hand, or perhaps they're doing it because they think it'll get them into heaven. In either case, they're thinking of themselves as much as they're thinking of someone else. So the person who takes their money and spends it on themselves is obviously thinking of themselves, but the person who takes money and spends it on someone else, well, they're also getting a good feeling, especially in a society which says you are a wonderful person, is going to give you accolades for giving away some of your money. Some people like that kind of publicity, that kind of feeling that they have moral superiority in some way because they've helped other people. And good on people who help other people. But don't kid yourself that those people have a certain selfishness. Now, is it the same kind of selfishness? I would say now, yes, it is. But my point is, I thought I was one of the first people to think the fact that even those who gave charity were selfish because they gave charity, because it gave them a warm, fuzzy feeling. In either case, whether you're buying something for yourself or you're buying something for someone else, you're getting this warm, fuzzy feeling inside of, yes, I've bought the thing and I'm feeling good about myself. So to me, it didn't seem like a huge difference. I could see, okay, it's good to help other people sometimes that really, really need it. But subjectively speaking, in terms of feelings, everyone's after that feeling of having done something good, buying something for themselves, buying something for someone else. Of course, I didn't think of that first, and it wasn't until many years later I encountered the work of Ayn Rand, who wrote this entire book called The Virtue of Selfishness, and she'd thought about it a lot more than I had. But I always thought it was a bad idea to call it the virtue of selfishness. I thought that's a very hard sell, given our culture. And I remember David Deutsch telling me, well, what can you do? And he talked me out of the idea that it was a bad idea to call the book The Virtue of Selfishness, because she knew what she meant. And why shouldn't she call it selfishness if in fact it was selfishness that was important? To do the thing that you want to do. And you should want to do the thing that you want to do because that's the fun thing to do. And it's selfish. And to be self-centered means you are really going to excel in the areas where you have the most fun, where you feel the best subjective feelings about yourself, where you're pursuing the thing that you enjoy. Some people are going to find a lot of enjoyment in giving away some of their wealth to other people, to be charitable. Some people might give away a lot of their time to be charitable, to help out others. And I think that's all for the good. Hell, I spend a lot of time helping people with my time as well. I also call that selfish, but I also enjoy it. I enjoy having conversations with people, helping people learn things, and giving up some of my time that I could otherwise use doing things like this. When people are doing the thing they find most fun, when they are being the most selfish, and that doesn't mean focused solely on doing nothing but lying, cheating, and stealing so that you accumulate all of the money and wealth that you possibly can. No, that's not what this is about. It's about having fun. Selfishness, properly considered, is about enjoying your life, flourishing, using your creativity, reasoning your way to somewhere better, generating knowledge, all of that stuff. So all of this is wound up together into a single unified whole about how best to live your life. When you do that, when you focus on the things that you find most fun, the things that you find most enjoyable, which are things where you're going to be most creative, you're going to be most innovative. You're going to come up with new ideas. You're going to generate wealth ultimately. Now, it might take a while and it might seem that the things that you're focusing on aren't actually generating wealth, but if you're really focused on the things that you find enjoyable, you will find other people, because although we are extremely different, we do have many things in common. And if you solve your problem, you might find that the solution that you find helps someone else to solve their problem. In other words, you've brought value into the world. And when you bring value into the world, people might be willing to pay you for it. And isn't that wonderful? You've generated wealth, you've created value, and other people are willing to give you money for that, to employ you, to donate to you, to trade with you, whatever it happens to be. And that's all for the good. Many people who are great innovators end up making a lot of money. So all of the great tech entrepreneurs right now, they've made a lot of money. Everyone from Bill Gates, who created Windows, and Steve Jobs, who created the iPhone, and Apple, and Elon Musk, who's got Tesla and many other things happening, they become multi-billionaires. Okay, what do they do with all of that money? They reinvest it. Because they've been having fun creating the thing that they think should exist in the world, they've generated value for lots and lots of people. Their products are valuable, and to the extent that they create value, people are willing to turn over their hard-earned cash. This raises the question of how much wealth is too much? None, of course, if the person who's generating the wealth is the person who is best at creating the wealth. It seems as though, at the moment, the richest person in the world, Elon Musk, is worth the most because he's the best at creating wealth. He's not stealing it from anywhere. He is literally creating stuff at Tesla, at SpaceX, on X, the platform, which other people find valuable. And to the extent that other people find it valuable, they pay him for it. And he takes that money and he reinvests it into the companies. And that means he can create yet more stuff and think more grand and more spectacular ideas and be more creative. If the government comes along and starts taxing him, then that means he has less money to invest in things which create wealth. The government is made up of central planners, politicians, people who aren't experts at generating wealth, people who aren't experts at creating anything, really, otherwise they wouldn't be inside the government. What those people are good at is often talking, like I am here now, arguing, debating, but not producing stuff, as people like to say now, building. They're not great at building unless they've come from outside of politics, from business or science or somewhere else, and then come into politics later on. Many of them are career politicians, so do not understand, generally speaking, what it takes to create and therefore what it means to have wealth. Because when you have wealth, it's not about sharing that wealth so that everyone has a fair share, but rather investing the wealth so that we can ratchet up the amount of wealth that exists on planet Earth, because then all boats rise with the same tide. It might be true that inequality increases, but inequality is not a bad thing. If the poor continue to get richer and richer and richer, then the rich can continue to get richer at a faster rate. And the only thing that is an argument against that is feelings, envy, that this could cause the poor people to be more and more envious of the rich people. But that is no argument. That's an argument for more reason, for those people to be critical of the way they feel. You shouldn't be envious of someone like Elon Musk. You should admire them, look up to them, and try and emulate what they do within your own domain of expertise, interest, and curiosity and what you find funny. You don't have to build rockets and electric cars and drill tunnels or have social media platforms. Focus on your thing. And if you focus on your thing for long enough, perhaps you can use it to generate wealth. There are no guarantees, but what is the alternative? To sit back and not try? To sit back and expect the government to give you money? To sit back and expect that someone's going to point a gun at Elon Musk and demand that he give you money? No, that is unreasonable. That is irrational. That is a way to dampen down creativity. We need more wealth in society. I've been saying this over and again. I've been beating a particular horse to death on this point, which is how expensive energy is right now. Energy needs to be far cheaper than what it is. The only reason that energy is so expensive is because politicians and influencers are prophesying what the future is going to be like. They are saying the climate catastrophe is coming or already here. And so therefore, we have to transition as quickly as possible away from fossil fuels and into renewables. And that process is costing a lot of money. Many of us can remember a few decades back where electricity bills were not as high as they are now, not making up some huge percentage of the household budget. But never mind the household budget, energy goes into manufacturing all the stuff that you buy at the grocery store. So all of your bills go up. All of the bills have gone up recently. For reasons of, well, of course, we did go through COVID, and most of the governments of the Western world and everywhere else decided to insist that lots of people didn't go to work. And so instead of those people going to work, they were put onto welfare schemes, and now we're paying for it. That's one reason. And the other reason is, to pile on top of that, is policies designed to prophesy what is going to happen with the climate decades from now. And this prophecy about what is going to happen to the climate requires us to believe that there is only one route to solve this problem, and that is using solar and using wind. Technologies which themselves are not entirely renewable. We know, for example, that there is a finite lifetime for any wind farm. There is a finite lifetime for solar panels. And certainly for batteries, these things last for 5, 10, 20 years perhaps at the most. So they have to be replaced. They have to be remanufactured. The materials have to be mined again. And as far as I know, many of them can't even be recycled if that's what you're after. There is a solution that we know in theory, but we cannot figure out in practice, which is fusion power. And as I like to keep arguing, it may well be the case that 5, 10, 20 years from now, we do solve the problem of fusion power. On the one hand, we could put all of our eggs into the basket of renewables and accept the costs associated with that, impoverishing various nations like Australia and the UK and America and wherever else it happens to be the case that they're moving away from coal towards solar and wind and spending all that extra money. Or we could put our eggs into the basket of just maybe people will continue to use the one thing they have which enables them to solve the problems that no other species can, their creativity, their capacity to come up with solutions to problems that they encounter. Because at the moment, it's a disaster. It's a disaster how much these renewables are costing. If instead we tended in the direction of continuing to double down on coal in particular, and other fossil fuels as well, then just maybe in 5, 10 years from now, we might have fusion power. There are no guarantees. There are no guarantees of anything. There are no guarantees, for example, that volcanoes aren't going to begin erupting. There are no guarantees that some terrible cosmic event isn't going to happen, like a coronal mass ejection or solar flare from the sun, or a nearby supernova, or an asteroid. Any one of these things could require us to have a lot more wealth than what we have now. And if we use the cheapest energy around now, we may very well be able to generate wealth at a faster rate because people will have more money in their pockets because they won't be forking out so much money for renewables. People keep on saying renewables are cheap. They're not. Any reasonable person knows we have to start believing our own eyes on this. When we look at our electricity bill and see how much more it is and how much more of a proportion it is of our weekly or monthly income, believe your eyes. The electricity is indeed more expensive now than it ever has been. And the huge problem is, and the reason I'm focused on it as someone who's interested in epistemology, is because when you force people into having no choice about a particular product, in this case electricity, the source of electricity, and you say to them, you have to buy this particular kind of electricity. It may be expensive, but we are not allowing you to purchase the cheap electricity, which is coal. Then what you are doing is stealing their wealth, reducing their capacity to generate wealth more quickly, reducing the capacity of the entire civilization to produce wealth more rapidly, to solve problems more rapidly. You are exacerbating the problems that human beings have. So I hope that in the new year, as we go into 2025, this air of optimism that I sense in some places continues to ramp up, and that people are more interested in how it is that we generate wealth more rapidly, how it is that we can be more creative and come up with better ways of producing knowledge that solves our problems and solves the problems of everyone everywhere more rapidly. Rather than having a group of experts at the top, the central planners, trying to dictate to everyone what the problems are that they should be solving. We should instead allow individuals to figure out what problems they want to solve and therefore keep their own money so that they can go about solving those problems. And focus not on what they say they believe, but rather on what they know, fallibly as always, how they can come to detect errors and correct them. This is what makes for a flourishing society. When people are allowed to keep as much of their wealth as they like, focus on the problems that they wish to solve, they have more fun. A society which has fun is an enlightened society. The more fun that's being had in a society, the more enlightened the society is. And when you look at things like happiness indexes around the world, never mind those, because some people don't know what they're missing. And so who cares if a certain group of people claims that they're happy? People in cults often say that they're extremely happy. No doubt certain psychopaths are happy as well. Happiness is an extremely bad metric. What is helpful is a freedom metric. The capacity for people to be able to choose what problems they're going to solve, to choose what to do with their wealth, and to choose what kind of knowledge they're going to create without intrusions from other people. They can post what they like on the internet without fear the government is going to be bashing on the door and arresting them or forcing them to use a certain kind of electricity. So here's hoping that 2025 allows us to leave behind what was the downturn during COVID and to come out of it being more optimistic. Because I remember hearing quite a few erstwhile optimists during COVID and at the end of COVID saying that in some way that they'd become far more pessimistic. I hope not anymore. I hope they realize that there is a real sea change in the air, at least, of people wanting there to be more rapid change, more rapid progress, greater wealth, more joy, if you like, out there in the world. I think 2025 is going to be an exciting, interesting, and good year. I will see you again then in 2025. But until that time, stay optimistic and have fun doing so. Bye-bye.